Okay, for this topic, we are going to look very broadly at the process of doing fieldwork. So I'm not going to get into too many details around excavation itself. My approach for this topic has traditionally been to kind of bring to light or to make less invisible the process of doing archaeological research in a field setting. So this involves not just talking about what research design looks like, but also talking about preparing for and going to the field, then talking about actual fieldwork itself, so finding sites, recording and mapping sites, and excavating sites. But then I like to wrap up by talking about some of the associated risks of fieldwork as well. So the reason why I want to begin with archaeological research design is that it should become clear at this point in the term that archaeologists just simply do not go out and dig holes wherever they want to find stuff, right? That what separates us from looters or pot hunters is that we are concerned about context, but we are concerned about context because it allows us to make interpretations about behavior in the past. And which behaviors in the past and what interpretations we hope to make is all dependent on the kinds of questions we ask, right? So we undertake archaeological fieldwork in order to answer specific questions. And for this, then we need to have a specific research design. So this is a short summary of the steps involved in archaeological research. And if you're interested in learning more about this, we spent a lot of time getting into all of these different components and really interrogating them in Anthropology 395, which is a course that I've been teaching once a year, every year. So again, if you're really interested in this, that's a good place to learn about this. But broadly speaking, we need to first and foremost begin by formulating our research. So coming up with what our hypothesis or our research question is going to be. We need to do a lot of background research then in terms of identifying what methods we can use to identify those questions, what parts of the world, what time frame we're dealing with. So all of that kind of context. Then once that's done, we can then look into implementing our research, and this involves a lot of work. So everything from obtaining permissions like visas and excavation permits and licenses to obtaining funding. I've mentioned this several times that archaeological research is expensive, so we need to ensure that we are not wasting funds, that we have appropriate funds in place to be able to do what we want to do. We have to acquire all of our equipment and supplies, including humans to assist us in this work. Then we can get into the field where we're actually doing data acquisition, and we'll talk a little bit about this today. Then we can get into data analysis, what we've been looking at in lab, including data interpretation, and then we want to look at disseminating our results, so things like publication. But really, it's more of a loop than a linear process. As students, you might be brought into archaeological research at kind of any stage in this overall research process. As a researcher myself, as someone who now is engaging in research or in directing research programs, I'm involved in all of these different pieces, and often at certain stages have to go back and revisit previous ones. So sometimes over the course of fieldwork, we'll encounter problems which might involve me going back and reassessing the research design. Same thing with analysis and interpretation. If we have insufficient data or if there's problems with the data we've collected, we may go back and undertake more research. So even though I'm showing it as a loop, it really is much more complex than just a linear process. So I already alluded to this briefly, but before we enter the field, there's quite a bit of preparation that we need to do. And the reason why I talk about this again is to make it less invisible, that as a student, I wasn't aware of all these steps. It wasn't until I got into graduate level work and my PhD in particular that I really started to see just how much, again, labor goes into preparing a research program and then to executing it to make sure it happens. So, I mentioned things like ethics clearance, approvals, and other things that we need to obtain. And in this image, you can see some of the documents that I've had to obtain over the years in order to do research in Tanzania. including visas to enter the country as a researcher, a research permit from the federal level Commission for Science and Technology, which is called COSTECH. Once I get my COSTECH permit, I can then get an archaeological permit. I don't have that here. And then once I get my archaeological permit, I can then reclassify my visa into what's called a residence permit C, which again allows me to do research in Tanzania. And so all of this costs money and all of this takes time. Plus, vaccinations are a consideration, booking things like flights and accommodation, packing all of our gear. All of these things take time and it's very labor intensive, as I've mentioned a few times. Then once we're in the field, before we even start excavating, there's a whole bunch of different things that we have to do, including acclimatizing to our work environment. Depending on where you work, this can look at like different sorts of things. It can involve setting up a camp. It can involve hiring accommodation or hiring staff to assist at the accommodation facilities or the camp facilities. It's a whole bunch of different kinds of things we can do. There's often legal requirements that have to be fulfilled. So in our case, we do office visits to introduce ourselves to government authorities at all the different levels, so city, regional, and federal level, so people know who we are, why we're in the country, and what we're going to be doing. And then once all of this background stuff is finally done, then we can undertake actual field work where we'll be gathering our data. So how then do we know where to excavate, or how do we even know where sites are that we can use to investigate our research questions? Well, here's a sample process of how we go about finding sites. The most common way is to do foot surveys. Of course, we can go to archives and check out history of the area. If there's an archaeological survey or archaeology branch that's associated with one of the levels of government, we can ask them about previously reported sites in the area. We can talk with local people, find out about oral history, see if they've seen material culture on the surface or if they know of any sites that are in the area. We can also research local geology and geomorphology. I'll talk about this in an upcoming topic about how site formation processes and where sites are preserved and found in different areas often is reflective of local geomorphology. So there's a number of different ways that we can find sites, and once we find sites that we then sample them. So in these images here, I have some pictures of my students doing a pedestrian or a ground survey and then doing some shovel testing or shovel test pits. And so these are small, like 50 centimeter by 50 centimeter holes that students or that we or anyone excavates in order to get a feel for what the subsurface deposits look like, what the stratigraphy is like, etc. But of course, it's not necessarily practical to walk the whole landscape, the whole region in doing surveys. So in some cases, we will do sampling, and there's a number of different strategies that we can use that are all based on grid systems. So we will establish a grid for our region, and then we can do simple random, stratified random, systematic, or stratified unaligned sampling, depending again on what our research questions are and what our overall goals are in terms of what we want to find and how we want to find it, and also what is the best use of the resources we have. We can also do aerial reconnaissance or take air photos. This was very common back in the day for archaeologists to use this technology, and the images here show the different types of photographs that could be taken and examined by archaeologists, and then also how we can interpret what we see in aerial photos in terms of archaeological sites and or features. And so you can see in this aerial photo here, you can see where there are some there's some discoloration that's occurring in this crop or in this field that's associated with buried or now removed structures, subsurface structures. And this is showing you why these different colorations are shown. It has to do with the composition of the sediment itself, how it's been impacted by human activity. So for example, we don't have a lot of soil depth or sediment depth here because of a buried wall feature that's present, but also how this impacts things like crops. You can see that where there's less soil depth, the crops don't grow as high, so we have a depression, and this might be visible from an aerial photograph. Or in this case, where a pit has been dug, we have a high crop because of the extra depth, but also probably because of some of the nutrients from this pit feature. Of course, we can use satellite imaging. There's a whole bunch of new technologies that have resulted, and as these technologies have shifted from military to commercial or public applications, things like Google Earth and satellite imagery have been increasingly used by archaeologists to look for sites where pedestrian survey is difficult or challenging, or to do kind of a preliminary survey of a region prior to actually getting our boots on the ground. We have a number of different types of, again, remote sensing techniques. These are non-invasive or non-intrusive, or at least minimally intrusive. Again, ways of us investigating potentially what is below the surface but is not visible to us. Once we find a site, well, then we have to record it. And so here I'm showing you an example of our site Megubike from Tanzania, and then how I would go about recording the site on a standardized form we have. We have to do a lot of maps and mapping. This is the subject of an upcoming lab, so I won't spend too much time talking about this, but maps are important not just for finding sites and developing surveys, strategies for regions, but also for recording, reporting, and interpreting sites. And so we map on a number of different levels. We always construct site grids. This allows us to establish the context of finds within the site. It begins with the establishment of a datum or a point of known location on the surface of the earth, and then we establish the grid off of our site baseline from that. Sorry, it always just takes a second for this to load because my map images are so big. Once we have our datum and our baseline, not only can we establish an excavation grid, but we can also map the rest of the site as well. So here's an overhead floor plan of a rock shelter we excavated in Tanzania in 2010. I can tell that because of the other information that is present on this map. And so you can see that there are large rocks and rock shelter walls that are present. We can see the grid that we built, including the 6 units that we actually excavated here. Here's some images showing that process of establishing the site grid. And so now you can see the inside of the rock shelter. This is the site datum here. And then the other lines and flags mark where our excavation units were placed. So we began initially with these 4 units, which we extended into a 2x3 block. And so we excavated all 6 of these units. Here is what an overhead shot of those 6 excavated units look like, plus what our plan view map of that excavated region looks like. Again, we can see that in this map we have focused on some of the rocks. This is roof fall from the shelter and how this impeded our ability to dig and excavate and recover finds. We also highlighted areas in which human remains were excavated, areas that were disturbed by rock removal or previous excavation in the area. And so maps become a really critical way for us to document not just our process of excavation, but what we're finding. And this then feeds our interpretations after the fact. We can also do feature maps. This is an example of a feature map we did for the human skeletal materials that we excavated from this site. And the reason why we did this as well is that we had human remains in more than one of our 1 meter by 1 meter excavation units, so we wanted to capture that accurately. You'll notice that not everything is represented exactly as it would be in the real world. So we just have a circle here for the cranium, but what is captured is the provenience of these finds. Some other things we have to do about doing field work involves the who's and the what, so it's not just about the where's and the how's. So field teams can be comprised of a number of different kinds of people with different levels of expertise and experience, and then your textbook does a great job of summarizing all the different kinds of equipment that we use and need when we are doing field work. And you note that it's not just digging equipment, but all of the equipment we need for drawing and documenting our site, for photographing it, for sieving or screening, but also just things for survival and safety. So in some images you'll see that I've posted throughout the term, we are wearing things like high-vis vests or pro bands or boots or hard hats, all of this different gear is required for us to do our job, but also to do it in a way that is safe. So when it comes to excavation, we have two goals, and I've mentioned this in our Collaborate sessions, that we want to recover as much evidence as possible, but we also want to do so while recording and maintaining as much of the context as possible as well, because again, without context, we can't make interpretations. Because excavation is destructive, we have to consider how we are going to excavate. Do we want to emphasize the vertical dimension and do a vertical excavation, or the horizontal dimension? And your textbook does a good job of providing some examples of the differences and explaining why we may choose one form over another. The reality is, even though excavation is destructive, we do this because it does yield the most reliable evidence for human activity in the past, and also for documenting changes in those activities over time. So here's some images from the Bodo archaeological site. I mentioned this a few times because I ran 2 field schools down there. So here's myself and one of my students, and this is a screening sediment that's been removed from the excavation block. Here, one of my students is excavating her 1 meter by 1 meter excavation unit in a quadrant system. So she's divided the 1 meter by 1 meter unit into 4 quadrants, which we refer to by their directions. So northwest, northeast, southeast, southwest. This again allows for finer control over provenience. Here's a student recording the provenience of a find within the site. And again, the mapping lab walked you through this process, and here are 2 of my students excavating within the excavation block proper. We have to record a lot of information when we excavate. Stratigraphy, as we'll talk about it in the dating lab and also in the dating lecture, is extremely important. So there's a lot of different information we have to record that becomes part of the context of the site. We use the stratigraphy to record not just associations, but matrix as well. This is showing you an image of a stratigraphic profile, and if you were to click on this image when it's not in presenter view, you can remove it and show what a photograph or what the real world looks like, and how we then translate that into a line drawing. And these are all the different ways that we describe then the different soil textures and colors that we see. Oh, here we go. I did have it where I've now removed it. One of the issues is I haven't completed the stratigraphic profile yet, and actually there should be some textures in here to show some of the distinctions. But what you can see is that what we see in the real world might be minor variations, but these could be really important in terms of, again, understanding the formation of the site and site formation processes like post-depositional processes like C or N transforms that have impacted the sediments and therefore the material culture in the site. And you can see here in this image, if we go back again, see lots of roots. And so clearly artifacts and ecofacts and other material culture in the site might have been damaged by these roots burrowing down into the sediment and pushing them aside. So we have level forms that we use to keep track of all of the information. So one of the ways we excavate is via levels. So these can be either by natural strata or layers of sediment, or they can be arbitrary. So in this case, we were excavating in arbitrary 5 centimeter levels, which is recorded here on this image. And then we want to document all of the other different kinds of things we see as we excavate. Of course, provenience is really important. So we record the provenience of all of our finds. All of our finds then go into little bags that are labeled with this information. We then put all of the individual artifact bags into a level bag, and so we need to keep track of how many level bags we're producing. And then we usually have some sort of inventory for every unit that we have excavated as well. One of the other things that we need to account for is the experiences of the archaeologist and how they shape our interpretations, but also the kinds of data we collected and how we collected it. So I've always had my team at the end of the day do a daily field report. This is a good way to kind of process and download or dump from our brain all of the observations we've made, all the interpretations we've made, all the things we're thinking about, and all the factors that might have impacted our excavation, and then allow us to kind of relax then in the evening and kind of stop doing the hard intellectual work that's associated with excavation. Different kinds of material culture are recorded in different ways. We'll talk about this in the bioarchaeology lab, that for burial records or for burial features, we have a different kind of record. There's a lot more information we want to record when we're handling and addressing human remains. Other features will have other kinds of forms. So this is a feature form we would use for this, which is a hearth or a fireplace or fire pit feature. Rock art also gets treated a little bit differently. Lots of information that we want to record. And so you can imagine that for sites, we have a really extensive documentary record. So here again, what I've tried to do is provide a generalized excavation flow chart. This is kind of what you would go throughout a day. You would excavate your unit, then you need to clean your unit, by which we mean kind of move things out of the way so that we can have nice photos when we photograph it. We need to do drawings of it or maps of our unit. We then can record our stratigraphy. We want to record any other forms that are required, make notebook entries. We need to make sure that everything we've collected has been screened and bagged and labeled. We might set aside some samples for things like dating. And then we're going to go back into excavating again, unless we have hit sterile deposits or sediment that no longer has artifacts in it, or ecofacts, which tells us that the occupation has potentially ended and we are done. So we're constantly going throughout this cycle on a day-to-day basis. Now, clearly we do this overkill because, again, as I've mentioned, archaeology is a destructive science. We destroy the archaeological record through excavation, so we need to make sure that we are recording as much information as possible. We also, of course, have limited time and limited funding, so we need to make sure that we're treating our excavation as basically as detailed as possible, and we're doing as much as we can as possible to not waste any time or funding that we have. Really, the amount of time we spend in the field is minor compared to all of the work we have to do before and all of the work that comes after that. Processing our finds, classifying and analyzing all of the material culture represent a significant part of our work. So here's an image of my students all set up at stations whereby they are involved in the process of dealing with the stuff that they'd excavated that season. We also have to think about the effects of fieldwork. There's a number of different ways that archaeology changes not just the knowledge that we have about the past, but also individuals who are involved in the project, either as informants, participants, or local community members, but also archaeologists ourselves are impacted by the process of doing field work as well. And so I've talked about some of my own experiences with this in my TEDx talk, which you could watch if you'd like. But while fieldwork is a very exciting time, just know that there are also some consequences as well that aren't as glamorous. Okay, so that's it for this topic. We'll revisit some of these as we go on and examine other aspects of doing archaeology, including our Week 7 materials, which involve relative and absolute dating techniques. And again, you'll get a chance to learn some of these methods, such as mapping, in subsequent lab activities.